In this video, you will learn the basic concepts behind neural networks, the mathematical models that power Neural Designer. A neural network is a mathematical function that learns patterns directly from data. It identifies relationships automatically by analyzing examples. It receives input data, processes it through multiple layers of interconnected neurons, and generates an output, such as a prediction, a classification, or a numerical estimate. A typical neural network has three main parts. Input layer, which contains the variables you provide to the model. Second, the hidden layers, where the network does most of the learning. And third, the output layer, which produces the final prediction, score, or category. Each neuron performs a simple operation. It computes a weighted sum of the inputs and applies an activation function. The network learns by adjusting its internal weights and biases. During training, it compares its predicted outputs to the actual values and computes the error using a loss function. Then an optimizer updates the parameters to reduce that error incrementally. This process is repeated many times until the model captures the underlying relationships in the data. Neural networks are robust because they can model nonlinear patterns, interactions, and complex structures that traditional statistical methods cannot easily capture. They work exceptionally well for tasks such as regression, classification, forecasting, and many others. Neural Designer implements neural networks using advanced numerical methods and optimized C++ code. This results in fast training, high accuracy, and robust models suitable for real-world decision-making. In the following video, you will learn how the complete machine learning workflow is structured inside Neural Designer.